morning, my dear students of class 11. So today we'll be continuing with our topic of electronic configuration in orbitals. So before discussing that, let's discuss about orbitals and its type. Okay, so we have s orbital, we have p orbital, we have d orbital, f, and so on. So here you have to know that in s orbital, and from our previous video, we had known that these orbitals are the exact the room for the electron. So s orbital will have just one room, and you have to remember that in one particular orbital, maximum of 2 electrons can be accommodated. So here, how many electrons? What is the maximum capacity of s orbital to hold the electron? 2 electrons. Why? Because each orbital will have the capacity to hold maximum of 2 electrons. Now this p orbital, from our previous discussion of principal quantum number and other quantum numbers, we know how many orbitals will be present in each of these orbitals. Okay, s, p, d, and f. So here, how many rooms are there in p orbital? 3 rooms, and it has capacity of holding maximum of 6 electrons, because each room, as I told you, will hold how many electrons? Maximum of 2 electrons. Now d orbitals will have how many rooms? 1, 2, 3, 4, 5. It will have 5 rooms, and maximum of it can hold 10 electrons. So these are electrons. Okay, the maximum electrons that can be held by this orbital. F has how many rooms? 1, 2, 3, 4, 5, 6, 7 rooms. Therefore, it has maximum of 18 electrons, which can be accommodated in this F orbital. So 2, 6, 10, 14. You have to remember it. And don't forget, each S has 1 orbital, P 3, D 5, and F has 7 rooms. Now let's discuss about shape of these orbitals. Now here you have to know that S is spherical in shape. It is what? Spherical in shape. So whenever it is involved in bonding, every time it is involved in bond formation, it gives you sigma bond. That is sigma bond, and this sigma bond is formed by head-on overlapping. Head-on overlapping. Okay. Now p orbital has a shape of a dumbbell shape. It has a dumbbell shape. It could be this way, or you can write it in this way also. Dumbbell shape, and it has the capacity to form both sigma bond as well as pi bond. So whenever it is involved in bonding, then it can form sigma bond. This is sigma, okay? This is not bond, it is bond. Sigma. Now whenever sigma bond is formed, as you know, sigma bond is reserved when there is a head-on overlap. Therefore, for this sigma bond to be formed, there has to be head-on overlapping. And as I told you, p orbital can form pi bond as well. This is pi, and you can write inside the bracket pi bond. It can form both, or it can form both sigma as well as pi bond. When is the pi bond formed? Whenever there is a lateral overlapping. Okay. So head-on overlapping, let's discuss about head-on overlapping first. What is hadron overlapping? Whenever two sigma bonds are overlapping in this fashion, like head to head, then this is known as a hadron overlapping. Now, whenever they are overlapping sidewise, means these orbitals are overlapping this way. In this way, these two orbitals, they have come together and they have overlapped in this manner. Then this is known as what? This is hadron overlapping. That means this will result in sigma bond, and this is lateral overlapping or sidewise overlapping, and this will result in the formation of pi bond. Okay, so this knowledge is required in your organic chemistry also. Therefore, we have to discuss this, and you have to know what are sigma bond and pi bond. Now, D has the shape of D orbital is double shape. That means you have this single dumbbell, then this is double dumbbells. Okay, you can refer to book if this diagram seems confusing. Double is one dumbbell, other dumbbell. Therefore, it is double dumbbell shape. Now, let's discuss about electronic configuration of orbitals. And this electronic configuration of elements, okay, is governed by different rules. The first one is of Babu principle. So, it's better to say electronic configuration of elements. Okay. So here, as I told you, this electronic configuration is governed by certain rules. The first rule that we are going to discuss is of Babu principle. Of Babu principle. This is very simple. Of Babu principle is very simple. It just tells us that. What does it tell? It tells us the electrons are filled from lower energy orbital to higher energy orbital. Okay? In simple words, electrons are filled in those orbitals which are having lower energy. Okay? First they are occupied, then they go, then the next orbital is filled, then this keeps on going on. So, then how to know which orbitals are lower or which orbitals are higher? Okay? Means they have higher energy. For this, you have a very simple way of remembering. And here it goes like this. Say, school, public, school, public, school. This is a way of remembering. Please follow this if you find it suitable and helpful. School, public school. Then comes Delhi public school, famous Delhi public school, famous Delhi public school. So school, public school, Delhi public school, famous Delhi public school, famous Delhi public school. Now what you have to do is, this is the order. Now you have to remember that it begins from 1. So 1, 4 s orbital. So 1s, 2s, 3s, 4s, 5s, 6s, 7s, 8s. Okay? Now, whenever we move on to p orbital, then it has to begin from 2. So 2s, 2. Whenever we come to p orbital, p, then we have to begin from 2. Okay, 2, not 1. 1 is for s. 2, then comes 3p, 4p, 5p, 6, 7. And whenever you go to the next orbital, that is the D, then you have to begin from 3. So 1, 2, it has to begin from 3, 3, 4, 5, 6. Now whenever we go to the next F, after D what comes? F. You have to begin from 4. Okay? So 4F, 5F. Now this is the sequence. That means this is the increasing order of energy levels. Okay? So 1s has lower energy than 2s. That means I can write in this manner. So this is very simple. You just have to remember school, public school, Delhi public school, famous Delhi public school and famous Delhi public school. This is what is given by above principle. So whenever any element is having say 2 electrons, then it has to go to this as 1s orbital first. Why? Because it is lowest in energy. Then if any element has say 6 electrons, then 2 electrons will be going to this orbital. As I told you, as maximum capacity to hold the electron is 2. So 2, then it goes to next higher, that is 2s. Then I told you we are doing the electronic configuration of element with atomic number 6. So 2, 2, 4. And here in 2p orbital is the next higher energy level, and therefore here 2 electrons will be occupied. The maximum capacity of p orbital is what? 6. So up to 6 it can accommodate. If it is more, then it will go to the next higher energy level. Hope this is clear. Now let's discuss about the other principle. After this above principle, the second principle that governs electronic configuration of an element is Pauli's exclusion principle. So Pauli, he tells us in a very simple words that an orbital, okay, if you have an orbital, say one room, then this cannot accommodate more than 2 electrons. That I have already told you. So the maximum capacity of this one orbital, each orbital is 2. And one more thing he says is what? He says that if 2 electrons are occupied in the same orbital, if 2 electrons are occupied in the same room or orbital, then they should be having, they must have what? They must have opposite spin. And you see that one is pointed outward, the other one is pointed downward. Therefore, it shows us that they are what? Having opposite spin. Now, what explanation does he give? He gave us that whenever 2 electrons they come together in a single room, then obviously there is what? There is inter-electronic repulsive force which tends to put them apart. But whenever they come and get together, paired up together, having opposite spin, then, please listen carefully, then this creates some kind of what? Magnetic field in this particular system. Then what happens? Now this magnetic field created will tend to cancel out the inter-electronic this repulsive force. Hope this is clear. Simple words. In each orbital, the maximum of 2 electrons can be accommodated, and if they are coming together in a single orbital, then they must have what? Opposite spin. Now the third rule that governs this electronic configuration is Hund's rule. Now this Hund's rule is very simple. What Hund's he told us? He told us that no pairing of electron takes place in the same energy level orbitals. Okay, it doesn't take place. First, they have to be filled singly. So let me give you an example that will be more clarifying. Suppose we are considering 3 orbitals. Say this is p orbital. Then whenever electrons are filled, then they must be filled singly first. Okay, they must be each each room, if they are having the same energy level, then they must be occupied first singly. Then only the pairing of electron takes place. Okay, this is very simple. If it is an s orbital, first one electron will occupy that orbital, then only pairing will take place. So let me state this rule. No electron pairing takes place in orbital with equivalent energy. Equivalent energy means now these three orbitals of p are having same energy level. Therefore, first they have to be occupied singly until each orbital in a given subcell contains one electron and the spin of any unpaired electron are parallel, that is in the same direction. So whenever they have occupied, suppose in a d orbital, 1, 2, 3, 4, 5. So electrons have to be occupied singly first in each subcell. Okay? And they must be having the same spin. Can you see that? In all of them, they are pointing in upward direction. Can you see that? And if they have to be occupied now more than this electron, then the pairing takes place and they must have what? Opposite spin. Now, the next factor that governs this electronic configuration is stable electronic configuration. You have to know that apart from these three principles, you have to know that if some elements are stable in certain configuration, in certain arrangement of electron, then they will be having that configuration. And for this you have to remember half-filled, and completely filled. Configuration is very stable configuration. Configuration is very stable configuration. Okay? So let us take one example. Let us take the example of say argon. You have argon and you know its atomic number is what? 18 and it's a noble gas. Yes or no? Now, how will you write electronic configuration of this argon? Now your previous way of writing, like you use this electronic configuration, say argon, when you were in class 10, you had it in the electronic configuration argon this way: 2 in the first cell, then 8, then 8. Total is 8, 16 plus 2 is 18. Now this way of writing is different from whatever we are going to write here now. Here, all these principles that whatever we have discussed so far today will be applied. Aufbau principle, it tells us what? Electrons are filled in what? Are filled from lower energy level to higher energy level. Therefore, 1s, 2s, 2p, 3s, 3p, then comes 4s. So, school is school, public is school, public is school. So, the maximum capacity, how many electrons are present in argon? 18. Maximum capacity is 2. 4. P's maximum capacity is what? 6. Therefore, it can accommodate maximum 6 electrons. So 2 plus 2 is 4, plus 6 is 10, 12. Then how many electrons are left? 18 minus 12 is what? 6. And the maximum capacity of this p orbital is 6. Therefore, now count 2, 4, 10, 12, 18. So this is how you write the electronic configuration in class 11. So S will have 0 electron, or you can write 4s 0, or if you don't write also, it doesn't make any difference. Okay? So let's take certain other example, like let's take calcium. Now calcium is 20. So 1s, 2s, 2p, 3s, 3p, 4s, then comes public school, then 3D, because D starts from 3. Don't forget, I taught you. So 2 is 4, 10, 12, 6. Maximum capacity is 6. So 18 and 2. That is 20. Up to here, you get these orbitals, these subcells are involved in occupying the electron. Okay, so you can write 3D 0, or if you don't write also, it makes no difference. Now, the same electronic configuration. Now look at it. The same electronic configuration can be written in this manner also. So instead of writing up to here, argon is noble gas. Then you have seen just now, it is a noble gas, so it has electronic configuration up to this 3p6. So up to 3p6, I can write argon 18 within the bracket. That means I don't have to write this part. If I write argon 18, then I don't have to write this part. Okay, since it is the nearest noble gas configuration of calcium. After that, what is occupied? 4 as orbital or subcell is occupied, and it has 2 electrons. So 18 plus 2. So you can write either this electronic configuration for calcium, or you can also write this electronic configuration for calcium. Both are correct. Now, at the beginning, whenever you are learning it, you are just at the beginning of this learning process, you better write in this manner, the upper part. Okay? And if you are going to write for large atomic number element, the electronic configuration, it is always better to consider this part, because you will be saving your time. Now, this is the electronic configuration. So now let's see example where this rule is valid. Okay, this rule, half filled and full filled electronic configuration. Now, before taking this particular example, let me give you an example, other example, like for, let's take, say, iron, Fe. So, in Fe, what is the atomic number of Fe? Iron, cobalt, nickel, copper, zinc, 26, 27, 28, 29, 30. So, its atomic number is 26. So, you can write in this manner. See, school is school, public is school, public is school, Delhi public school. So 1s, 2s, 3s, 4s. So 2p, 3p, then comes 3d. So 2 electrons can be occupied. 4, 10, 12, 12 plus 6 is 18, 2 is 20. So how many more electrons are present? 6. So these 6 electrons will be occupied here. The maximum capacity of D subcell is what? 10. Don't forget. So it can easily accommodate this 6 electrons. Okay, this is the electronic configuration of Fe26. Now let me give you an example of chromium now. So scandium, titanium, vanadium, chromium. So its atomic number is 24. So whenever you are writing it, 1s, 2s, 2p, 3s, 3p, 4s and 3d. So chromium, manganese, iron. So its atomic number is 24. Try to fill the electrons here. 2, 2, 6, 10 plus 2 is 12, 18, 20, then comes 4. Yes or no? So whatever you have learned till now, if you don't apply this fourth, say we can say law, then according to you, this electronic configuration is correct, and you will be expecting marks in your examination, because you will be thinking that this electronic configuration is correct. But listen carefully here. Half filled and completely filled configuration is very stable configuration and is the preferred configuration. Now let me tell you that Here, the maximum capacity of D subcell is what? Holding 10 electrons. If it is holding 10 electrons, then how many sublevels will it have? 1, 2, 3, 4, 5. Yes or no? This S has, this is D and this is S. S has only one, this subcell where 2 electrons can be accommodated. Now if this rule is applied here, then you can see that if one electron from this S is gone to this D orbital, then what can we have? We can have, so up to here exactly the same thing you will be having, that is 1s2, 2s2, 2p6, 3s2, 3p6. Now if one electron from here is sent to D orbital, then you will be having 4s1 and 3d5. Please look at this part very carefully. Now, what does it mean then? It means that this S will be having 1 electron and this D will be having 5 electrons, which are what? Unpaired. Now look at it. Now whenever this 1 electron is sent to this D orbital or D subcell, then this is also half filled and this is also exactly half filled. This is also exactly half filled. Therefore, now according to this rule, this is the actual configuration of chromium, and this configuration is what? It's wrong configuration. Okay? I hope you understood this one. Here, this is wrong, and whenever this 1 electron from S orbital, S subcell is sent to D orbital, then both of them they become completely half filled. This is also completely half filled. Maximum capacity is 2. It is having 1 electron. The maximum capacity of D subcell is 10. It is exactly having 5 electrons in its subcell. Therefore, now this becomes the actual electronic configuration of what? Chromium, and this is wrong. And actually, it should be having what? It should be having which configuration? 4s1 and 3d5. So this is the correct electronic configuration. So such case also exists with what? Copper. Now similarly, if you have understood this, you will be able to do the electronic configuration of what? Copper. Copper, okay? And copper, nickel, copper, zinc. Therefore, its atomic number is 29, and to write its electronic configuration will be your assignment. Please do it. Try to apply all the rules, and don't forget to apply the 4th rule, half filled and completely filled, because it is based on that. Okay? It is based on that. So, in your book, you have other electronic configuration also. If you have any doubts, you can always WhatsApp me. Thank you. Take care.